When building a class, you're probably going to include class members like methods and data members, and also properties. Properties allow your object to store, manipulate, and retain the data that it needs. So in some senses, they're very similar to member data or member variables, in that they provide storage for data. But properties are much more robust than data members. Properties are used to manage access to elements of an object. Through access modifiers, we're going to be able to control the accessibility of your class members. With properties, you've got the opportunity to do things that you don't have the opportunity to do with data members. For example, when someone who's using your class passes a value, those values can be validated. Additional code could even be executed, or other tasks can be performed when the data inside your object is set or retrieved. Properties are really methods, but they have a special configuration. They have what's called a get and a set assessor. These assessors are what are called when the data is set or retrieved. In this example, what I've done is I've created a public class called employee. That public class has one data member called salary. You can see that the data member is publicly available, which is generally a design flaw. It's not desirable. Let's take a look why. In this example, what I've done is I've created a reference type of employee, and I've instantiated a new employee. So I now have an employee object. What I'm able to do now is I'm able to access salary directly, and you can see the result of that. This is not a valid salary. And by allowing a consumer of your class or an object to directly access the salary data member, what you've done is you've not allowed yourself to validate. So there's no validation opportunity at all when dealing with public data members. What we'll look at next is trying to take those data members and make them private. Let's see how we might be able to set or get those data members and still keep them privately available. That means they're only available within the class themselves. Take a look at this example. This seems to alleviate the issues that we talked about in the previous example. We still have the same public class, it's called employee, and we have the same data member, it's called salary. But notice that the salary data member has actually been demoted to a private level variable, and you can see that right here. Now remember, the idea is that that will give us a lot more control over that data member. If you take a look, two methods have been added, one called getSalary, which simply does a read or ask for the current state of salary, and setSalary, which actually will modify or write a value to the salary data member. Take a look inside the setSalary. What you have here is a parameter. When someone calls the setSalary method, they're going to actually pass in the value that they want to set the salary to. But notice that there's validation here now. What I can do is I can interrogate what they've passed in. If sal amount is greater than 0, then I will change salary to equal whatever the sal amount is. But notice, because I've encapsulated the changing or the writing of a data member inside of a method, I have the opportunity now to actually do some validation. This is a very simple example of why you want to demote data members to be private. One of the things we talked about is to actually change the data member inside of a public method, and that allows you to step back and interrogate the value before you actually make that change. Now, this is a really great example, and I think it really hits home on why you might want to demote your data members to private. But there's still something missing here. And here's what we've got. we've got someone who's going to be using your public class, and in order to access the salary data member, they have to remember two methods. And we want to make it easier on them. And that's where properties come in. Properties allow you, through one method call, to either read or write a data member. Let's take a look. In this last example, we still have the same public class called employee. We still have the same data member. Notice that it has been demoted to a private level variable, which is what we're recommending. And then we've got a property. Now remember that a property is really just a method. If you look at that top line, that looks like a method structure. But the difference is that inside a property or this special method is what are called assessors. This is a getter and a setter. What the get does is it actually grabs or returns the current state or value of salary. You can see that right here. In the set, a set is a write or a change to the salary data member. So you can see that what I've done here is I've assigned salary equal to value. Value is an intrinsic variable, and you can access that in a property method. So that is available to you within C#. So what you've done here is within one method called a property, you have the capability of doing read-writes of a data member. So the get is a read, and the set is a write. Let's take a look at creating an instance of the employee class. Here I have an instance. X is the reference type. And in that first line, what I've done is I've called the property. Remember that a property is merely a method. It's a special type of method. Now what I've done here is I've called the set component of the property because I'm changing the value of the current salary. So X dot current salary, I'm calling it just like a method, but notice there's an equal sign in the line, and that's what I'm passing in. So actually 25,000 is what is passed in right here. I know that I'm calling the setter or the set component because of how this call is configured. So what I'm doing is I'm attempting to write or make a change to the current salary. In the next example, what I'm attempting to do is simply get or read the current salary. So I'm assuming y is just an integer variable equal x dot current salary. So once again, I'm calling it the same way I would call a method. But what this is really doing is it's calling the get component, because really all I want to do is read the salary. So this calls the set of the property, and this calls the get. Now, unbeknownst to the user of my class, or the object itself, X, I have no idea that what I'm really modifying or what I'm really reading is this salary data member, because it's not available to me. It's not visible to me. I don't see it. But all I know is that I'm calling something called current salary. And that's really all I need to know. So what I've done is I have actually encapsulated the reading and the writing of that data member inside that property. In this way, I have complete control over the salary data member. For example, here, what I could do is validate what they're trying to pass me before I set salary equal to that value. For example, if they're trying to pass me something like a negative number, I can go in and I can create some kind of validation in the set. So once again, I've got some great opportunity to validate what's being passed to me. Not only that, but in here what I could really do is write some more code based on the fact that salary is being modified. For example, I'm going to go ahead and let them modify the salary value, and then maybe what I want to do is incorporate some code that changes a salary field in a database table, for example. Using properties to set, get, maintain my data members is really the way to go, because it gives me the most control over the data members or the state of my object. It allows me to validate what is being changed about the data member. It allows me to read the data member. It allows me to even execute code based on the setting or the getting of that data member.